Hi Praveen, how are you?
Hi, sir. How are you, sir?
Good, good. Thank you.
Ridutta? Uh, Praveen, sir, we will start in 5 minutes. Mr. Chaitanya is joining. Okay, okay, right. Good afternoon, Chaitanya sir.
Very, very good afternoon, sir. Sorry, just I think I missed my password.
No problems. So I think since Chaitanya sir is also here, so we'll start the session.
Yeah, let us start. Let us start.
So
Sorry.
yeah, good afternoon, everyone. Good afternoon, Anku sir, Chaitanya sir, and Praveen sir. So welcome all the participants to the day 3 of the webinar. So today we'll be talking about the role of sustainable materials in the construction towards net zero. So day 1 was the inaugural talking about energy efficient buildings and all, and day 2 we spoke about renewable energy in the construction industry, and day 3 we are talking about this materials. So first I would introduce about our Chaitanya sir, who is co-chairman of IGBC Belgavi chapter and MD Chaitanya Associates. So he is also a secretary for CREDAI Karnataka State and also Honorable Secretary for Builders Association of India. So Chaitanya sir, I would like you to give a welcome address and set the tone for today's session.
Yes, yes. So thank you very much. Thanks for the nice introduction. Though it is a bit old, but I think it's my fault that I have not sent you the updated one. That's okay. And friends, welcome all of you for this great celebration of World Green Building Week. My dear friends, very good afternoon and warm welcome to the day 3 of this interesting webinar series organized for this week celebration. In this webinar, I think we'll be deliberating on the role of sustainable material in achieving low carbon building. The building sector plays a critical role in achieving India's ambitious net zero goals. Today, we are here to explore the strategies, innovations, and the best practices that will shape up the future of sustainable development. Friends, the responsible selection of building material is very crucial when you design to construct a building. By procuring and incorporating eco-friendly or say eco-labeled building materials, it's eventually achieve the desired results. Besides the key areas in green compliant project like sustainable design, energy efficient measures, water and waste management, the use of sustainable materials contributes really to the great extent to achieve this, the goal that what all of us are just thinking. The core building materials such as cement, steel, bricks, etc. have huge impact on the carbon footprints in a building. Now the question is whether the carbon footprint is to be increased or reduced. But we have abundance of low carbon building materials available today with the reduced carbon footprints in the most of the categories, be it in steel, cement, bricks, high performance glasses, which could be considered to use to make a building achieve a low carbon emitter. Besides these core active building materials, there are ample other materials which is also recommended to be used during the operation and maintenance of the buildings like coats, cleaning chemicals, water saving devices, low carbon energy appliances. Such buildings and projects should also be regularly monitored on the carbon generation and reduction of the necessary measures are considered to be taken further. With the global focus now shifting towards the climate change, we have seen a lot of countries, including our own India, committing to be the net zero in emission by 2040 to 2070. If countries were to achieve net zero emissions, sustainable building design and sustainable building materials plays very, very important and vital role. Hence, it is very important to understand what the present trends and technologies in sustainable building materials and products are. And if we were to achieve the vision of net zero, what would be the trends in the technologies for the future and what would be their advantages? So today we are really honored with us to have two distinguished speakers who bring a wealth of expertise in this field. I welcome Praveen Kumar Somaji, the Principal Counselor of IGBC, and also Architect Ankur Sanghvi, the Principal Architect of AMS Architects. I'm confident that their presentations will inspire us to think deeply about the challenges we face and the solutions we need to implement for a carbon neutral future. Let's take this opportunity to engage, learn, and collaborate for more sustainable tomorrow. I think the panelists today are going to enlighten us about this. And really, we are blessed to have both of you who have got great expertise in this. Thank you very much.
Thank you, sir. Thank you for that welcome note and setting the context. So I would like to introduce the first speaker of the day, Mr. Praveen Kumar Soma. So he got his bachelor's in architecture from SPA JNTU. With having over 22 years of experience, he specializes in green building project execution and net zero LCA and all other things, with over certifying over 3,000 plus projects in his career. So he also works closely with GBC on the terms of advancing net zero projects since 2016. He also handles Green Pro division in CI. So welcome, sir. Welcome to the webinar day 3 series. Sorry, webinar series day 3.
Yeah.
So I would request you to take over.
Thank you. Thank you, Sridatta. And thank you so much, Chaitanya, for giving the welcome remarks. I'll just share my screen. Sridatta, just confirm me once my screen is visible.
Yeah, it's visible, so you can go ahead.
Thank you so much. See, my topic is paradigm shift in design thinking, especially with respect to the building materials. And we would like to first welcome everyone to the World Green Building Week. We're celebrating from 9th to 13th of September. And it is actually very promising to see so many people actually registering from the 9th September. We are seeing that we have been, I think, close to 800 to 1,000 people are actually watching us both right now live and also through different mediums like YouTube and other portfolios. That's good to see. And also to see young people actually registering more, and that means they are very promising to see that they are going to see how the net zero transition will also be happening soon. As I told you, my topic is the paradigm shift. I'm going to talk so many things which relate to past, current, and other future, how it is going to happen. As you know, before 2015, okay, many stakeholders, okay, were leading by example, which means that nobody is actually pushing them. They actually voluntarily walking the talk. Okay, you talk about Godrej, you talk about Wipros, you talk about ITCs. Everybody champion the cause of going green by setting an example. They're actually inspirational buildings. Okay, starting with our own CI Godrej GBC building in Hyderabad in 2002. And today we are talking about so many building projects actually. That is only because many projects already implemented on the ground to showcase, inspire into many architects today. Then we have seen launch of Green Pro, okay, in 2015 in the same thing. Before Green Pro, we used to actually take declaration from the manufacturers saying that my product is green. They declare that 15% recycled content, or maybe I'm sourcing from 400 kilometers, 500 kilometers from this so-and-so location. Okay, we should depend on the declaration of the manufacturers. But once we have the Green Pro Eco label, now there is completely due diligence is completely cleared actually, because it is a third party type and eco label, hence that is completely avoided. And just by having a Green Pro certificate, we used to clear the projects now. Post 2016, we have seen expansion of IGBC rating programs. As you know, we only had the IGBC new building rating programs and IGBC green homes rating program, as you know. And I think of 16, we expanded to almost 34 rating systems, depending on the building typologies. The ratings have been emerging actually. We developed the rating program with the help of a lot of stakeholders who are actually maybe part of so many developments that you have seen, maybe transit, maybe railway, or maybe the green homes, which is developed by so many 100+ stakeholders. Then we developed green cities, we developed green townships, then we developed post 4-5 years back, we developed the net zero energy, water, waste, and last year we launched the carbon. It is not easy actually, but with every evolution, we actually upgrading the rating programs also, which actually is actually shifting from green buildings to green built environment. And as I'm talking now, I think many projects, we have close to 116 projects precisely have registered in net zero segment. Okay, if you ask me 3 years back, it is very few actually, maybe 1 or 2 projects only every year we have seen that they are actually working on net zero designs. But today, as I'm talking, more than 100 projects are going green in net zero. That means now the transition is already happening. That means when we visualize the green buildings, when we visualize built environment, but is it possible to go to shift to net zero? Yes, it is possible actually. Our own building, which has got platinum rating way back in 2002, 2003, with highest rated, and today it is also shifted to net zero platinum by design, and net zero energy by platinum by design. That means there is a self-sufficient building. Whatever energy we consume close to 2.2 lakh units per annum. We have solar panels which are bifacial in nature, 135 kilowatt. They generate close to 2.3 to 2.4 units, 2.3 lakh units per annum. That means it is whatever we require, it is generating more than requirement actually. It's called self-sufficient building. So that is already so that is also very important to see, exhibit the existing building and also go green or go net zero actually. That is very important. Today, as I'm talking, I think the future is all about net zero, with vision from Prime Minister also talking about 2070, moving towards net zero segment. So we should also divert our all attention to more net zero projects, even though we may have a handful of projects today, but definitely in next 5 or 10 years, you may see 1,000 projects aiming for net zero, also implementation also on the ground. We may see more technology is going to happen. So I've now fixed my focus onto the paradigm shift in the design thinking, how it is transformed. Okay, for example, way back when we started the journey, the conventional electrical demand, if you take 1 million square feet of a commercial building, okay, the electricity requirement is close to 10 megawatt. 10 megawatt is required for 1 million square feet of a commercial building. Okay, but what these green buildings did is just half the requirement. That means the load on the infrastructure is completely down actually by 50%. So that means when a building or a community goes green, the load on the infrastructure is decreased by almost 50%. That means for the same 1 million square feet, these green buildings designed such a way that it only requires 5 megawatt. That is the change it has brought. So we never thought it can brought to 5 million directly, 5 megawatt directly by that is the extent of designing actually. Similarly, air conditioning, conventionally, if you remember, definitely that we design open offices in a commercial building like thumb rule of 180 to 200 square feet per every ton of air conditioning. But green buildings have already showcased. In fact, our own GBC building, we designed screw chillers, 50 tonners. We designed for 1 ton for 350 square feet. That means 1 ton of air conditioning will cool 350 square feet. Okay, we have seen Pocharam ITC Infosys building in Hyderabad, which is around 6 years back. They designed their own identical buildings with radiant cooling technology, where they're able to achieve 1 ton cooling more than 650 square feet. So that is already happening. That means the efficiency of the chiller, the efficiency of the air conditioning system also matters a lot actually. That means initially, suppose my design capacity is, let's assume, 100 tons. Okay, when you change going for an efficient chiller, suppose your design capacity come down to maybe 50 tons or maybe 60 tons instead of 100 tons. Okay, that means the initial investment also decreased. But of course, the cost of the system may be three times or maybe 4 times. But in the long run, definitely have a savings actually. Okay, so this is very shifting paradigm shift happening in the air conditioning division. Similarly, we have seen the lighting reduction. Way back, I think people will remember the T12 tube lights where we used to have 55 watts choke, and we have seen T5 transition, we have seen CFL transition. Okay, when you compare with a T12 55 watt with a simple T5 26 watt tube light, the lighting lux level is same, but the power consumption almost 50% reduction. Okay, and of course with the advent of LED lights, LED tube lights today with 10 watts, 12 watts, 15 watt tube lights, okay, the lux level intensity is almost equivalent to what we achieved 10 years back or 20 years back actually, but the wattage is much reduced actually. In fact, we used to talk about 1.5 watt per square feet almost 20 years back. Then with the advent of green buildings, we thought 1 watt per square feet is the baseline. Then today we are talking about less than, I'm showing 0.4 watt per square feet, but many projects achieved 0.3, 0.35 watt per square feet actually. Okay, because of sensors, because of natural light intake into the space, so many things have taken in the design. So this is much reduced actually as I'm talking to you. The water consumption. How many of you remember NBC 205? Okay, 2005. That version we used to talk about 150 to 200 liters per person per day for a residential building. Okay. Similarly, 45 to 60 liters per person per day for a commercial building. That is a baseline set by National Building Code. Okay. After once you get National Building Code updated, the green buildings have done a different benchmark actually. We used to have 75 to 80 liters per person per day in a residential projects, then less than 15 liters per person per day in a commercial building actually, because in commercial buildings only the urinals will be there, only the water closet, there are no showers, but the consumption is much lower in the commercial building. Similar residential also, we are seeing the consumption per person per day is actually reduced due to the efficient water fixtures. Okay, the change in the water fixture that we do. For example, let's assume you're taking a water closet. Suppose you got a single flush with a single system, one flush 10 to 15 is gone actually. You suppose you use 6 liters 6 times in a day, that means 6 into, let's assume 10 liters, 6 liters is gone. Whereas when you go to dual flush, okay, dual flush, and use one time for a solid flush, 5 times for liquid flush, that means 1 into, let's assume it's a 6 bar 3 kind of a dual flush. 1 into 6 is 6 liters, 3 into 5 is 15 liters, that means close to 21 liters against 60 liters is actually saved actually. So that is the amount of what is the transition happening in the water fixtures also. So everywhere by design today, all the projects that you see by design, they're actually going for a green, even though they may achieve the rating or not, but by by design through NBC rating, with the national codes, with other standards, by default projects are actually decreasing the consumption also due to sustainability impacts. When it's the role of materials, how materials can impact, okay, in terms of both energy efficiency and also indoor air quality. I'm going to touch upon these things. For example, you take conventional building, okay, that means you don't have any knowledge of green actually, but you construct. What will construct? We'll use red bricks and we do RCC slabs, columns, everything, okay. But when you plan right in your site, okay, you will never give any thought process of having a natural light. We never give thought when having the ventilation standards, whether it is energy efficient building. We never give any thought process actually. That means in terms of energy efficient envelope, we never give any thought process of this one, okay. And for example, you go to Mumbai, okay, there is no space between one building to other building. That means there are no setbacks. We already seen with our own eyes that even though got a plot area, they will construct entire plot area. You're not even leaving a 5 feet setback. Very, I mean, tight that all 3 sides is completely packed. Only one side which is facing the road, maybe having the windows or doors. Other sides, even though you have a window, there is no possibility of achieving any light or views because other buildings also blocking it. Because every plot owner wants complete of his site to be completely blocked. That is the conventional construction I'm talking about. Okay, what is the change that we got in the green buildings? Okay, the green buildings, with the help of all the stakeholders, when we develop the holistic framework, we developed such the building envelope itself should be energy efficient. That is a complete paradigm shift. That means the material which we use for the external facade should actually reduce the heat ingress. How you change it? You change the brick to a different material. You change the glass with a different material. You have more openings. Okay, in terms of bringing natural light into the interior space. That means we are giving more emphasis on the daylighting with a proper methodological approach, with how much percentage you should have opening to the window size to the floor area ratio. We are giving that kind of a dimension so that it is measurable. We have very clearly measurable matrix for daylighting. Similarly, ventilation. How much ventilation is as per, suppose for example, you're going for green buildings and commercial building, we talk about actually 62.1. Okay. For example, you go to residential buildings, we talk about having at least 10% openable windows with respect to floor area. That is the kind of a baseline we give setup. Okay. Similarly, we also address heat island effects. That means building is there, suppose they got a lot of glass, it also actually gives more heat islands to the neighbors. Okay, we want to reduce the heat islands through more green space, more vegetation. Even though you have materials, the materials which will have a lower SRA when you use at the ground level, it has got a higher SRA when you use at the roof level actually, so that the heat islands also addressed in the green buildings. Similarly, when you use the construction materials which will be eco-labeled, that means third part is verified that there are no toxins. These materials are having low carbon compared to other materials, and they're using recycled content by default. Okay, we talk about water savings when you use plumbing fixtures, which is actually saving water 30% or 40% less than the baselines. We derive baselines from Uniform Plumbing Code of India, where we do water saving for each plumbing fixture or water fixture. We have the baseline. For example, water closet, you got a 6/3 dual flush. For taps, we say 6 liters per minute. That is the baseline. And when you use the tap with the aerator, it comes to 3 liters per minute. That means 50% water savings in the just by tap actually. Okay, waste reduction. We say that in the green buildings, right from the design to end of the construction, we actually monitor actually in terms of what is the construction we are actually doing it, how much construction waste we actually generating. That means in terms of concrete, in terms of cement, in terms of steel, in terms of aluminum, in terms of sand, so many things. We list everything and we'll see metals easy to recycle, because anybody, even if throw somewhere also, the metal go to mapping facility only. But through net zero waste rating program, we said let us do recycling, because if you see Indian capacity of recycling, it is less than 2% recycling capacity in India actually. That means construction waste generation, there is no recycling capacity in India today. We have just less than 2%. That means we require every state, every city should have recyclers so that we can actually recycle many materials other than metals, like maybe wooden products, maybe the glass, maybe the aluminum metals or other areas. So many list of materials we have, so that all the tiles, all the ceramics can actually go to recyclers and they can actually use this as raw material and produce the new materials actually. Of course, when you move from green buildings to net zero, with same design concept, that means the building should be green first of all. Then they should think about reducing the energy by design. That means through envelope, through other active measures, through air conditioning or through lighting, efficient lighting. Then they should actually step onto the net zero building actually. That means first they reduce the energy demand. Then they will actually install the on-site renewable energy, so that the buildings becomes truly net zero actually. Similarly, they will actually talk about water. They should do harvesting of water, rainwater harvesting. They should do. Yeah, sorry.
The slides are not changing.
Great.
Yeah, if you can just restart
the conventional green buildings and net zero.
Yeah, that is the slide.
That is a slide. That is a slide. Yes, that is a slide.
Okay, we are getting some messages from the participants.
Okay, it is the same slide only, because conventional green buildings and net zero in the same slide it is there. So when we talk about water, we talk about rainwater harvesting, one area, other area, whatever water you consume in the building level, you actually use it and treat in the on-site through a STP. And once you treat the STP, once again reuse for water for flushing needs or landscaping needs. That means whatever you're getting from municipal, or once again balancing through rainwater harvesting and also the STP treated water actually. That means that also you're actually definitely going to have net zero water also possibility. Similarly, waste to landfill also we are trying in the net zero concepts. Let's talk about wall assembly. What are the options? You take a conventional simple red bricks. Okay, the U value is close to 2.5 watt per square meter degree Kelvin. Whereas like you take a stone wall, it is around 1.25 watt per square meter degree Kelvin for a 300 mm stone wall. Whereas when I shift from conventional red bricks to autoclaved concrete blocks, the U value downs to around 0.6 watt per square meter degree Kelvin. What is U value? U value is a thermal conduction. That means the temperature difference between outside to inside. Outside is 40 degrees, you want how much? 24. That means from 40 to being 24, okay, the heat which is there outside will come to inside, right? To stop that one for longer time, you require lower U value, okay? That means when you change the material, instead of red brick to AAC blocks, it can actually have more insulation. That means it stops the heat for longer time, and the load on the AC will be reduced. That is the intent of U value actually. So always look for what is my U value of a wall assembly. When I say wall assembly, in complete the thickness of the wall, what you constructing actually. It can be concrete wall, it can be a porotherm brick. The porotherm brick is also having a lower U value of 1.2 watt per square degree Kelvin. Similarly, people are now actually using sandwiched panels of XPS, that means thermocol and also concrete, so that they get a lower U value also. It's called as structural concrete integrated panels. These are some of the things happening in terms of research also happening. Only glass, we can say two things. While when you put a glass, right, you'll get two things. One is natural light, definitely is there, but it also brings heat. So when you are designing a green building, we actually as a designer think in different directions actually. That means you think on first, how can I reduce the heat ingress into the space, also getting the light into the space. That is the challenge actually here. That means we balance between the U value, that is thermal conduction, also the solar heat gain coefficient, and also VLT, visual light transmittance. These are three things you should balance when you have designing a green building. Okay, normally VLT means visual light transmittance. We have a simple plain glass has got almost close to 0.9 actually. That means whatever light is there, it will come to here, and also brings the heat. Okay, you cannot balance. Okay, similarly solar heat gain coefficient, that is like a shading device for the glass. You have very high shading coefficient, that means more heat enters the space. Normally in the cold climates, we used to have more SHGC, 0.75, 0.8 we require, because we require heat coming in inside. But heat is coming inside, but we cannot stop, right? That means we should also have lower U value to contain the heat. Once the heat is coming into the inside space, we should not let the heat go back. So we should have a lower U value. So the baseline is of a glass is close to 5.7 watt per square degree Kelvin. But when we go for an efficient glass, it will come down to 2.52 watt per square degree Kelvin. Sometimes when you use DGU, it can come as low as 1.5 to 1.8 watt per square degree Kelvin. That means when the glass is DGU, that means mostly when there is very hot, okay, regions like Mumbai, Kolkata, okay, regions where in the west and south facade, okay, there is a requirement of DGU because there is hot ingress which actually increases load on the air conditioning. Commercial buildings where have a lot of facades, I think there that we normally prefer DGUs actually. Okay, and there's something called a light to solar heat gain coefficient. Okay, in case if it is less than 1, okay, we actually consider as a simple baseline. When it goes above 1.5, 1.6, 1.7, it considered to be economical and also efficient glass for a green point of view. So when you talk about eco-labeled green pro, okay, we have baseline set here 0.5, 0.33, greater than 1.5, less than 1.5 watt per square meter Kelvin. That means glass actually made these parameters actually in the green pro eco label. Similarly, cement is one of the material which normally we use in all the buildings, every construction, plastering, concrete, RMC, everywhere, right? First, you should understand when you take a OPC, ordinary Portland cement, okay, the carbon is close to 950 kg CO2 emission per ton of a cement. Okay, then what is changing in green buildings? In green buildings, we promote Portland pozzolana cement and pozzolana slag cement. That means the cement content is replaced with fly ash by a certain percentage. For example, 30% of the cement is replaced with fly ash, or 40% of the cement is replaced with GGBS. Okay, what happens is the carbon content is reduced. For example, let's assume you got a PPC. Okay, the PPC, the carbon footprint is close to 650 to 700 kg CO2 emission per ton. That means already the carbon reduced by almost 250 kgs actually. When you use instead of OPC, you're using a PPC. When you use PSC, slag cement, the carbon content drops to almost 450 to 500 kg CO2 per ton actually. That means almost 50% carbon is decreased. That means you can proudly say, this is a building. When I use OPC, this is my carbon footprint. I used PSC, that's why the carbon footprint is 50% lower. That is the example you can set. Similarly, there are additive content in CC. For example, instead of brick, suppose you use AAC blocks. The AAC blocks, the carbon footprint is 80 kg CO2 per cubic meter, whereas brick is almost close to 250 kg CO2 per cubic meter. That means almost 170 kg CO2 is actually decreased. Okay, when you use AAC blocks instead of clay bricks, that is embodied energy can decrease, and you can calculate accordingly numbers. So everything is measurable, intact, when you actually go with eco level products also. Similarly, I will introduce one more material called pervious concrete. Okay, the name indicates concrete. That is absolutely right. Okay, for example, you take 6,000 square meter of area. That means close to 60,000 square feet. Okay, if you take a rainfall intensity of just 100 mm rainfall, that means close to Jaisalmer, where 100 mm rainfall, right? And runoff coefficient is a property of material. For example, 0.95 means when you pour the water in a material, at the end of the material, you can actually capture 95% of the water actually. That's called runoff coefficient. For example, you have a sand. If you pour water, what happens? All the water actually goes inside. It means runoff coefficient almost 0.1. There is no chance of water actually coming from the soil, sand, right? Everything actually goes inside. Similarly, you got a high grass. Okay, when you pour the water, at the end of the grass, you can only capture maybe 50% or 40% only, because all the water which is coming from one end to other end, by the time it comes, evaporation happens. Also, it actually percolates also the soil. So the runoff coefficient is very important parameter. For a pervious concrete, when you compare to conventional concrete, it is 0.5 to 0.6. That means it actually slows the runoff, about percolates the water inside, and also there is chance of evaporation also. Okay, that means it also helps in rainwater harvesting. For example, you take the same 6,000 square meter of area. In the case of conventional, there is no chance of rainwater harvesting actually. Everything goes to runoff or drains actually. Whereas when you use the same area with a pervious concrete without changing any strength of the concrete, you can still save 37% of the rainwater actually, by just changing the water content. Sorry, the material change in the concrete actually. It's called pervious concrete. So this actually we should use mostly in the driveways, paving areas, so that instead of just using the hard paving everywhere, okay, which actually shows, of course, clean and tidy, but it doesn't actually serve the purpose, because usually high-tech city in Hyderabad, one rain, 30 minutes rain, it actually floods. All the water, even though you see water, but at the end of day, there's no water actually. Everything goes to drain actually. We cannot save any water. But by just changing a simple material, okay, by going with pervious concrete, you can save at least 37% of the water going into the aquifers actually. That means you are increasing the water table. Very, very important element. Only in the green buildings, we shifted from conventional designs to biophilic designs. What do you mean by biophilic? Okay, for example, we have external landscaping. We say that at least 15% of the landscape site area should be landscaped actually. That means vegetation, or it can be a natural topography. That means when you not disturb the mother earth, what happens? We're actually keeping the food chain intact. Suppose you cut everything. For example, you go to Bombay, you are actually digging from compound wall to compound wall dig actually. There is no space left of it. They'll actually keep all the materials in a neighboring plot. Okay. So what we're saying is, when you have that's why we're missing sparrows, dragonflies, due to there is no landscape element actually. Okay. We are bringing outside landscape, plus we also promoting indoor landscaping. That means indoor plants, which actually are natural air purifiers. We have selected some 27 indoor plants. You can find this list in the interior rating program in the annexure A, where, so for example, you take a money plant. It's a natural air purifying plant. It can replace the air purifier actually. So you have, suppose, 10 plants in a room. They actually increase the oxygen levels. For example, areca palms, snake plants, they're also less maintenance actually. Suppose a plant you want to use in a washrooms, you can only use fern plant because of high humidity levels. Suppose the plant you want to use in a parking area where the CO standards are very high, you can only use fern plant, which they can absorb actually. Similarly, do you know a plant which can actually generate 24-hour oxygen? It's only Tulsi plant, which generates 20 hours oxygen, 4 hours nascent oxygen. That means it also is capable of getting ozone, O3 also for 4 hours. This is a very, very important element of indoor plants, because it actually absorbs all the toxins. So there are so many volatile organic compounds present in the materials which actually emit. How can I show you example is, for example, you're going for vacation, you lock the house and go back. After 10 days, you come back, and just first time when you open, right? What do you feel? How you feel? All the materials actually give some kind of a smells, right? It's called as volatile organic compounds. They actually gives more smell. It can be fabric, it can be sofa, it can be your drapes, it can be all the materials which are there, paints. all this actually show as a VOCs, and after 10 or 15 years, actually, you may get some kind of a bronchitis, asthma can be aggravated actually by these things. But these plants can actually help in air purifying. So this is also one of the concepts we promote in green buildings. So these are the plants. You can see these are snake plant, areca plants, money plants, peace lily. These plants actually we promote in the interiors. It can be a home, it can be a commercial space, it can be any space. We can actually promote these plants. Similarly, we are going to touch upon something on the green procurement circularity, which is a futuristic actually. In this first element will be when you demolish a building. Okay, for example, you have a old building stuff, and you had a client brief that you want to design a new building. Okay, you should pull down the building, right? But how you pull down? There is a methodology to pull down also. We call it sustainable demolition. That means you should first see when you pull down a building. First, see whether this building is actually can able to retain as it is. That means it has got strength to go to next 40-50 years. That will be a true green building because it's already taken all the resources from the earth. So in case you want to pull down, you should go with a structural engineer. If you say that it is not, it cannot be structurally stable, then it will be pulled down. If he says that it's structurally stable, the best way is to actually extend the life for next 30-40 years by just doing a simple renovation actually. Okay. In case the structural engineer says you can pull down the building, then you demolish the building such a way that recover maximum material from the demolition. That is very, very important. So you should have a very clear mapping how to capture each material. It can be iron, it can be a timber, it can be bricks, can be old doors, old furniture, the other equipments in the building can be once again reused also. And identify recyclers so that you can hand over to all this demolition waste recycle actually, because it actually creates an opportunity to develop recyclers in multiple cities. As I told you, recycling is very important in India. When you use the construction waste properly, okay, we also promote materials which are made from C&D waste, construction waste. For example, you can talk about coarse sand. Sand is not available today. River sand is not available. We are talking about depending on the manufactured sand, actually M sand. We're talking about recycled aggregates, which are crushing of the stone aggregates. These are all can be made by using of construction waste. Okay, wood waste you can make MDF boards, particle boards you can make. You have a lot of construction you can make paver blocks, you can make curved stones. We're already seeing these things happening in today actually. Earlier, very rare to see this one, but today, by design, they are actually thinking in direction who are actually aiming for a net zero waste kind of projects. We have been seeing these things happening actually in reality. For example, when I talk about material circularity, which means that this building, what you're seeing, is designed by Romy Khosla in Delhi. It is Volvo Escher building. What you're seeing is the railway sleepers. That means old stuff, old timber blocks. When they put an auction, the railway sleepers, the auction they got very cheap rate, so they bought it, and they use the building facade element. It has a shading element actually. Of course, it doesn't take any load, but actually acts as a shading element to the entire facade. Similarly, being a Volvo building, they have a lot of wood crates, pine crates. They brought when they bring the Volvo machines, they actually are the pine crates. This being just a museum kind of a thing. In some areas, they got all these models. They brought the pine crates, and they wanted some around 1,500 workstations. Okay, the architect had designed the workstations using the pine crates. That means the pine crates can be just put together and packed and dumped into the landfill or maybe sold to some recycler. Okay, but he actually designed the furniture made up of pine woods because it may take 10 years and 15 years they will want to use life. That's all. They will want to once again replace, right? So that is what they're going to use workstations, functional elements, decorative elements like ceiling elements, so many areas. So what I'm saying is, it is about how you think. For example, you think that this material is waste, and if you think that this material is I want to use in somewhere, that is the change in the green actually. The very thin line when you're talking about go to landfill, where I want to extend the life of next 20 years for a material, that is a change in design thinking actually that we want to we do in green buildings. Similarly, this architect in Ahmedabad designed his office with old doors. Almost you can see that it is a 80-year-old door actually. Okay, in his office, this door has become the what is a landmark element actually in their office. That means this door actually attracts that. Okay, client also remember very clearly that I actually visited one of the architectural office where I've seen a very old door of Haveli actually. Ahmedabad, Gujarat is very famous for their own doors and designs. So they actually kept that heritage and structure actually. Similarly, you see that old chairs it seems that architects' childhood chairs have been retained as it is an element. And I used the veneer samples in the shops as one of the design element in his own entry point. That also is actually good to see. But when you see as a waste with eye, right, you may not be creative. But when you see with that same element and uses the different functional element, when you see actual see after the construction, and that gives a completely different meaning with your functionality without compromising on the strength, structurally everything. This is already happening in the green buildings actually. That's what metal circularity are all about. And many projects are also actually doing. For example, I use carpet, new carpet today, okay, and I sign an agreement with the carpet vendors that after my 5 years or 10 years, once I want to change the carpet, I will take back this carpet actually. That means the carpet vendor will sign with the client that of 10 years of this life, I will take back this carpet. I will give a new carpet. This carpet which is there will actually go to as a raw material to a new carpet actually. That is also actually happening today because of the standard take back policy. Only this is one of the one more element. The old fabric samples in the catalogs, right? They've been used as one of the sofa furnishings. You can see the old cycle things have been used as one of the elements in their own chairs to actually engage their own team members. We also promote rapidly renewable material. That means instead of using a teak wood or a sycamore which takes 30 years or 40 years, okay, we can use timber which can be harvested in a cycle of less than 10 years. For example, bamboo, rubber wood, sugarcane, okay, eucalyptus. These would actually harvest very faster. In case you're unable to find these things, you can always go for a engineered wood. That means it is not a real timber, but it is made from wood and chips. Okay, that also is actually promoted because, as you know, world is losing forest cover equivalent to land of Greece every year. So that is very, very important on our designers, architects, young engineers. They should actually see how we should move towards alternate construction. For example, steel, in 80 years, we don't have any steel. In maybe 60, 70 years, or maybe grandchildren will see coal in museum, because when you are highly dependent on the coal, there is not available of any raw material actually. Without steel or coal, very difficult to actually get all our oils, so many things we depend on the coal, to our electricity, steel, buildings we can't be imagine, right? But now we should shift our thinking towards alternative construction materials. We should not decrease the dependence on the virgin resource and move towards alternative construction. Coming to the segregation part also, we normally see segregation means dry and wet waste segregation, right? But when we see in one of the projects, okay, we are seeing segregation for a simple dry materials include Tetra packs, milk packets, newspapers, plastic packets, plastic containers where you order the food, right? They'll give you a plastic container, old paper newspapers, then paper shredding. That means after you complete the paper, you shred, right? Shredding, this one, Tetra packs, milk covers, tissue papers. Different types of tissue papers can be office tissue paper, it can be toilet tissue paper. Both are different completely. E-waste, plastic covers, multi-grade plastic covers. Plastic, there are a lot of very destructive plastic. It can be hard plastic, it can be food container packing plastics, which are packaged kind of plastics. Thermocol plastic. These are so many dry waste you have seen. That means the project is actually thinking very, very deep actually. Normally, when you see a green building neighborhood, they'll just stick it actually. Dry waste, segregation, over. No. Many projects in IGBC, actually they're thinking how they can go to next level actually. They are doing in letter and spirit. That's why I'm showing all these examples. People may think dry waste means 3 varieties over. No, it is actually going to depth actually. What I'm showing still is only maybe 60% actually. Maybe still there are so many projects are doing much better actually. Similarly, when I talk about segregation of it looks very simple. You require a sorting facility. That means when you have a large variety of waste generation happening in the projects, you all require sorting facility. How you sort different materials put together. That means you should also always dedicate a space for sorting. Then only the segregation actually happens. It may look very simple, but it is not an easy task. Also, all the wet waste. Many projects, almost 90% of the projects, has got this OWC in place or some other means to treat the wet waste actually on the site. Some projects actually going up slightly and going for a compact biogas converters. That means they're generating their own gas. Instead of LPG gas, they're generating the biogas, mostly in the kitchens, the requirements, commercial buildings I'm talking about. So, and of course, the manure which is coming from the OWC, they use for landscaping. So it's all are actually happening in the green building projects. That means when you think just segregation of this one, that is only a starting step, but many people are doing much beyond actually. When you talk about net zero, these all things happens. Procurement. As an architect, it is a change happening from his side. For example, when he has a 10 line items in his bill of quantities, okay, he sees that how many materials are eco-labeled. For example, steel, we have almost 35 to 40 companies has got eco-label. Cement, almost all companies in India are got eco-labeled actually. RMC is once again the product of cement. Concrete once again comes cement. That means we address glass, cement, steel. That means already 60% of the cost is done actually. We are eco-labeled. So that means any architect when he picks the eco-labeled products for his construction, main construction blocks, cement, aluminum, glass, and this one's TMT bars, his 50%, 60% already covered in the eco-labeled products. Balance, he should see how many products actually he is designed with C&D waste products. That means he should have a qualification for materials which are actually sourced from construction waste, demolition waste. That then only the recycling industry will actually grow. That is our thinking actually. Similarly, how many the wooden products, now coming to wooden products, how many actually are rapidly renewable materials or salvage material? That means without depending on the virgin timber, which is having longer time, and also we are actually wasting a lot of timber. Old timber, how you actually once again bring to life for next 20 years, that is what talk about salvage materials. Similarly, alternative construction. How much percentage can be alternative construction? It can be M sand, it can be MDF boards instead of real timber. Like this, you think of alternative construction materials is also one of the criteria. Similarly, bio-based, that means whether I'm making with a bagasse, sugarcane waste is called bagasse actually, making any products with bagasse or some other products. Okay, this is a green procurement kind of a initiative. Many developers, many corporates actually instituting now. That means earlier procurement is on a division, but in the procurement itself, the procurement managers actually now are very knowledgeable than us, that they're asking whether the product is green. Okay, let me give an example. HDFC Bank across the pan India, when they have this bill of quantities, everything, they demanded eco-labeled furniture, which actually made we had only 1 or 2 furniture companies with us in, 3 years back. Today we have 50 furniture companies. Why? Because the client is demanding that I want a eco-labeled furniture only, because they have pan-India branches and they want to source only local furniture. That means the manufacturing facility should be local only. They cannot source from Jammu to Kanyakumari or Kanyakumari to Jammu. They only want Bombay, means only Bombay. Kerala means they want to source the furniture only from within the Kerala. If it's not possible, then they will go to one more city next to each other. Okay, that means it's demanded. The client is demanding that I want eco label. That means actually every manufacturer in furniture actually come into eco label or green pro. So it actually happens, and that is what it is moving towards a green procurement today. So it's a very powerful tool for net zero, because when you have a low carbon cement, when you have a low carbon concrete, when you have a low carbon RMC or steel, which are actually reducing your design embodied energy. Of course, operational carbon is once again, it takes 40-50 years, which is a continuous dynamic process. It happens, but at least the design is taking control on the construction materials actually. So if you see all the one of the what to say, the material, the sheet of a IGBC project I'm showing you, where you can see a list of all the materials on the left hand side, description, RMC, steel, sand, so many materials. Okay, why I'm showing this sheet is almost 93% of the by cost are eco-label products. So that very clearly given the name of the organization also, which has got eco-label company. Okay, location, everything is Kolkata project, with distance, everything. This is how the projects are submitting. Earlier we used to have dedicated, just very tentative manufacturer actually, whether he is there or not, we don't know. But here we can verify very clearly. So for example, they say it is Ultratech cement. I can verify from our own certificate that Ultratech is there or not. Okay, cement company is there or not, we can check actually. The panache, whether it is there or not, we can check actually. Everything by company they are listing now. This is how the project submitting today. That is the once again transition happening. Earlier I told, right, declaration 15%, 20% resale content. Today it is completely changed. So you take a building, you take any part of the building, we have eco-label product today. So we have close to 9,000 products available with eco-label. We have the 38 categories of whatever product you say in the building construction is actually eco-label. So we can go to caigreen.com and take the list see the certificate, see the eligibility, their validity period, and accordingly you can actually use in your bill of quantities also. So thank you so much. Any questions I can take or I can wait. Thank you so much. Yes, Siddhartha, I'm done.
Thank you, sir. Thank you for that wonderful session. I think we have a couple of questions from the participants. I think one question which I can see is who is expected or supposed to ensure that ECBC norm as specified in EC Act 2001 are being actually implemented?
ECBC Act.
ECBC
Yeah,
norms.
Yeah,
EC Act.
I understood the point. See, when you talk about green buildings, right? We always keep the local national codes as the baseline. Okay. For example, right from beginning, we say that okay, this building, commercial building, we should say ASH 90.1 for energy. Okay, with a baseline. Okay, Uniform Plumbing Code of India for water. Okay, and water central pollution control board norms for the pollution control boards. Like this, we given the baselines. Okay, what the green buildings have done it, they not only meet the baselines, they do 30%, 40% better than the baselines. That's why they achieved it. Okay, you just meeting the baseline, they will not get any rating program. They will just only meet the mandatory requirement only. Okay, where you see gold, platinum levels, right? You must have hearing the project saying I'm silver rated, I'm gold rated, kind of thing, right? That means they're actually, when they achieved performance, they're actually exceeded the baselines by 10%, 15%, 20% action. That's why they actually rated that high. And baselines are not, see, some cities it's mandatory, and even our IGBC rating programs is not mandatory, for your information. All these 14,000 projects which are going green with IGBC as on date with 12 billion square feet are actually voluntary. They are not mandatory. Still, our rating system is voluntary only. And we keep these baselines as mandatory in rating programs. Hope I think I address this query.
Hi, sir. And we have one more question from the Q&A session. So, what is the minimum peak demand achieved in office complex? What's the square feet?
Sorry, again, can you tell me?
What is the minimum peak demand achieved in office complexes?
Peak demand means in terms of what? Air conditioning or the electricity? What is it?
Water consumption.
Water consumption. See, I told you, right? We always measure with respect to Uniform Plumbing Code of India. Okay, so they have baselines and we're done. We already seen more than 50 to 60% projects have achieved savings in the water savings. Energy has seen almost 30 to 40% in savings with respect to Einstein 90.1 or ECBC 2017 also. So many projects have done extremely well. Then they have gone for renewable energy also. So many projects have done very high, whatever you was saying, peak demand, whatever was there. In green buildings, the design is completely different actually. We never talk about peak demand, we talk about some other element. So that's a complete different version. We never believe in the peak demand. We believe in something called as I forgot the name. Maybe Ankur Sang is knowing. So we actually we take both transit, permanent, so many occupants, and come out with a FTV number. It's called as full-time equivalent. Then we design our green building projects.
They're also asking about minimum peak demand.
See, that's what it's all completely different actually. It depends on project to project. It cannot be just one figure. And I don't know what is the intent from where it is coming, the question, because it has a lot of things. It can be talking about fresh air, it can be air conditioning, it can be electricity. So many things are there. It's not direct question, direct answer also.
Okay, sir. I think we don't have any more questions in the chat box also.
Thank you.
Okay. So that's a wonderful session, sir. Hope all the audience got a good overview of what Praveen sir just took you through. So I will just take this opportunity to introduce our next speaker of the day, Architect Ankur Sangvi. So he's an architect with master's degree in energy climate from Arizona State University. He designed the first LEED building in India, that is the Saurabhji Godrej Green Business Center, Hyderabad. He's also a co-chairman for Envelope Committee Efficiency. So he's also a executive committee member who took part in developing certain IGBC rating systems in green home rating system and existing building rating system. So he's also a member of National Building Code Committee for the development of new chapter level on sustainability. He's also a part of an integral part of many IGBC rated green building projects across the country. Sir, I would request you to take over the session and continue with the presentations.
Thank you. Thank you so much. Can you hear me?
Yeah, sir, we can hear you. You can just share your screen.
Okay. And can you see my presentation now?
Yeah, yes, sir, we can.
Okay. Good evening to everyone. I think Praveen has taken us through a very, very detailed and a very nice presentation where he has presented a lot of thoughts. So he has actually made a lot of my work easier. So my presentation will be a lot shorter than his. I'll just take you through it. Now, I just wanted to bring forth the amount of construction that we are going to be doing almost every year in the country. Today we have a urbanization ratio of about 30 to 35%, and any developed country, if you see, has a urbanization ratio of about 70%. So that means that the number of buildings in the urban areas are going to probably double in the next 15 to 20 years. That means that we are going to be adding the equivalent to probably one New Delhi or one Mumbai every year. So that is just to give you an idea of what is the scale of construction that we're going to be looking at, number one. Number two, what I also wanted to bring forth was that if you see the amount of greenhouse gas emissions which buildings are responsible for, so that is almost 40% of the total, where 28% just comes from building operations and a significant 12% comes just from manufacturing the materials that go into constructing a building. So coming from this background, I just wanted to highlight what is the definition of sustainable building material. So there is this old definition which the World Resources Institute had come up with, where it defines sustainable building materials as those that are produced, used, and disposed of in ways that minimize environmental impact and promote long-term efficiency. Now, after that, there have been a lot of iterations, and now you actually have sustainable materials which are defined as those that align with the principles of environmental stewardship, resource efficiency, durability, and health considerations. So now there are two more aspects that we are talking about over here. You're talking about durability as well as health considerations. If you see, there are now five main features of any sustainable building material or any building material that can be called sustainable. So one, it has to be environmentally friendly, have a low impact on ecosystems and biodiversity, reduce energy consumption, lower carbon emissions. Second is it has to be resource efficient, where it uses resources in a very optimized manner. Then you have something which is called the circular economy, which I'll actually show you with my next slide. And now you also have this health and safety, where the material should be such that they contribute to healthy indoor environments by not emitting harmful substances. So this is the VOCs that Pravinji was talking about earlier. And the last one over here is that they should encourage long-term durability, so that if the material has a long lifespan, it reduces the need for frequent replacements. So this is the basic general definition of sustainable materials. Now, when we talk about life cycle cost analysis, what happens is that we are just not talking about manufacturing the material. In fact, the whole life cycle of a material is divided into four parts. So you have stage or module A as it is called, which talks about extraction of raw materials to actually manufacturing the raw materials. Then you have section B, which talks about how to maintain and use the operational part of the material. Then you have section C, which is the end of life. So, you demolish the building material, you haul away the waste, how is it recycled, how is it disposed? And the last one is, beyond the life cycle, and how can the waste or the debris be actually, useful or recovered or reused? Now, when we talk about a circular economy, what happens is that your section D over here actually becomes section A1, and this whole linear module that you see turns into a sort of a loop where the waste again becomes the raw material for the new products that are going to be made. Oops. So, what is the approach to using sustainable materials in buildings? The first one is that, if you look at Carl Elefante's words, the most sustainable building is the one that is already built. So the idea is that, if you have existing building stock and if this can be retrofitted, without having any major changes, make it more efficient, put in more, put in a better quality of glass over there, put in roof insulation, put in high reflective paint on the roof, and you actually retrofit the building and extend the life of the building by say another 50 to 60 years, then that is the most sustainable thing that you can do. That is the most sustainable, material that you would probably have, which is your existing building. Tata Sons House, the Bombay House that you have in Mumbai, and ACC House are prime example. You also have a lot of these old Havelis and fortresses across Rajasthan and Madhya Pradesh, which are now being retrofitted into hotels, into resorts. So these are prime examples of how buildings can be reused without having to build again. Aisha House, Praveen has already shown you. But what I would like to point out over here is not just the fact that sleeper wood has been used, but the fact that we as architects, designers, and I do not know how many architects we have in the audience today, but as architects, we need to think differently. We need to approach the problem differently, and think innovatively. Three very, very classic examples. On the top left, you have this whole wall, which has been made with disposed of water bottles. Then you have this nomadic museum, which actually moves I think it moves every year or every 2 years to a different location. And it is actually made from 40 shipping containers. And between the containers, the space that you have, I don't have that photograph over here, is actually supported by columns that are made with reinforced cardboard. So it's a very innovative use of what would have been a waste material and also a material which can quickly be brought down and put up somewhere else. And the third shot that you actually see is the WRI's own office in Washington, where what they have done is that all the chairs are actually made from seat belts of cars that have been disposed of. So, junk cars, they've extracted the seat belts and made chairs from these seat belts. So the point that I'm trying to make over here is that, we need to think different, we need to think innovative, reuse of or salvage rather of what would potentially have been waste material. Local materials have always been a low carbon alternative. It reduces the emissions which are related to transportation dramatically. Also, local materials tend to require less amount of processing. They support the local economy. They reduce waste because the waste can be again reused in the manufacturing process. There's preservation of biodiversity and is climate responsive. what I've seen as an architect is that if you look at the local construction techniques or the vernacular architecture of any location, it'll actually give you clues on what is the best material to use in that particular climate. If you take the example of Rajasthan or Gujarat, where I belong to, you have a lot of stone that is the local material over here. And probably in terms of environmental response, stone is the best material, that you can have for that particular climate. Or if you go to, say, a coastal region like Goa or to coastal Karnataka, you have a lot of laterite which is being used. So, wherever you have the local materials, that gives you the best clue on what would work for that particular climate. Uh, in the recent years, we have come across a lot of materials which are now being touted as green materials, which are probably genuinely green materials and are being, researched into and being developed. So there is this tile manufacturer in Bombay who actually say, and this manufacturer is a group of architects and engineers where that tiles do carbon upcycling. So they actually take waste carbon from the environment and use that to manufacture the tiles. So that is probably a very sustainable way of manufacturing tiles. Then you have hemp block. Hemp is a natural material. You have the Manila hemp, and this hemp, when it is combined with lime, it forms a block which will keep absorbing atmospheric carbon dioxide throughout its life. And then you have straw bale or thatch, which also absorbs or sequesters atmospheric CO2. So you have these materials as well, which are very, very sustainable materials. But the problem with all of these materials is, even whether you talk about these new materials, whether you talk about local materials, that none of them are actually scalable. Today, if you are having a skyscraper, which is say a 30-story building or a 200-meter building, or, which is what is going to be the need of the hour, we cannot actually have any alternative for either cement concrete or for steel or for aluminum. So I just identified this set of 6 materials which are such that actually if you want to scale up construction, which is what is going to be the need of the hour, because we are going to be building what has been built in the last 50 years, we are probably going to be building in the next 10 to 15 years. So the scale of construction required is fantastic. And these are the materials which will actually help us achieve that scale of construction. And for that, we need to figure out a way on how to make these materials a green material, or at least make them less environmentally harmful. When it comes to steel, there are multiple processes of manufacturing steel. So you have, the most popular, which is your BOF furnace steel, and then you have your electric arc furnace. Difference between the two is that you have a very, very high recycled content, which is possible with electric arc furnace. And if the source of energy for electric arc furnace is solar photovoltaic cells, then your carbon footprint of EAF manufactured steel is about 30 to 40% lower than your conventional steel. Similarly, Pravinji also talked about green cements. So I'm going a step beyond, what he was talking about. You have this ferrocrete cement, you have Ecomax cement, you have geopolymer cements. All of these cements actually use different chemicals, and they are manufactured in such a way that they absorb a good amount of CO2 from the atmosphere, and they can actually be turned as green. Unfortunately, what happens is that the cements work out to be very expensive because they are not used very frequently. So, there's this classic case of what comes first, the chicken or the egg. But if we start using more and more of these green cements, and if the volumes increase, we may actually be able to bring down the cost of green cement. With glass, you again have a way in which there are manufacturers who are talking about ways in which they can go about making the glass production more green, more resource efficient. But how do we incentivize all of these manufacturers to put in money into R&D to actually go about changing their production lines to make products that are more environmentally friendly? So again, you have this eco-labeling that Praveenji was talking about. So you have this environmental product declarations, and you actually use products which have these EPDs. Then these products are green. And what happens with EPDs is that they follow certain principles. So you have this life cycle assessment, which is cradle to grave, which is done for a EPD. You have standardization. They follow international standardization codes, 14,025, 15,804. So these are typical standards that are used for making green products. They actually mention what is the quantitative data of your GWP or your global warming potential of a particular material, your ozone depletion potential of a material. So these EPDs include all of this data, and also you have this modular approach that I've written at the bottom, which is very important, where the declaration actually gives you that what is the amount of resources which are being used at different stages of manufacturing of a typical material. So, even if you look at cement, you know that there are five manufacturers, they are using five different projects, I mean, sort of production lines, and you can figure out that which is the greenest one which would work for a particular project that you have. CII IGBC has the Green Pro, and Green Pro also follows most of the parameters. I mean, there's a convergence with EPD to a great extent, and for certain parameters, Green Pro actually goes beyond a few of the EPDs. So, what is the way forward? Uh, This way forward is something that we use for a lot of our green building projects, where first we define what is the overarching goal of the project. I mean, if the project is genuinely want to go in for a green certification, they just want to look good, feel good, or they are actually going all out green. So define the project objectives, set the priorities within the budget, because what happens is that whenever we are talking about what are the goals of a project, we have very lofty goals, and when we start talking about these numbers, that how much is green cement going to cost you vis-a-vis your regular. If your regular is 360 rupees a bag and your green cement is about 600 rupees a bag, are you willing to spend that much? And that is where we end up the losing the plot of going green. But if these priorities are set within the budget itself, then there's a greater chance of implementation of the green strategies. Develop measurable matrices, where we actually figure out whether we want to go in for a IGBC rating system, or we just want to make sure that we have a recycled content, which is say 60% in our project, or we want to ensure that more than 75% of all our materials are, manufactured within a certain radius. So, set out this measurable matrices. Establish roles and responsibilities. If you have a cost consultant, you need to tell him early on that this is the main objective of our whole exercise, and you are responsible for ensuring that we fit our aims within a certain budget. So establish this set of roles and responsibilities to ensure that the objective is made. And then, there's this track and review mechanism, especially mid-project, that, sometimes what happens is that projects tend to meander along at their own pace. And, some of the key parameters that you had set up earlier tend to get lost. So need to have a mechanism for or track and review. And most important is, document the results, publish the results, give the results to an agency like IGBC so that they can actually create a national database which can be used for promoting green materials, for ensuring that, manufacturers who go in for a green product get certain SOPs from the government, get certain incentives from the government, so that, the whole process of going green gets pushed forward. Would just like to end up with a quote by Sir Norman Foster. The choice of materials for sustainable construction is not just about saving the planet, but also about designing better environments for people to live in and work in. Thank you.
सर आप करके चाहिए मैं ड्राइंग और
Thank you, sir. Thank you for that wonderful session. So, I think we didn't got any questions from the participants yet. So all we got is some good appreciation from the participants in the chat box. Ankush sir, I think we don't have any questions to take on from the participants.
Good.
So, Chaitanya sir, you want to add something on this? Or?
No, it was really great presentations, and really the subject is made very clear for all the attendees. And Praveen sir, it was really wonderful to see all those kind of plants that what you have demonstrated about specific, especially about the Tulsi and all, actually how, and it makes us feel so proud that all our buildings, the ancient buildings that what we have, and all, the knowledge of our ancestors, what they had, really they were, it was really great. So, and if on behalf of IGBC regarding these plants, if we can just circulate few of the plants which can be used inside, outside, with those this thing, I think that shall be also can be circulated in the social media for the better understanding of the common man.
Sure, sir. We'll try to do that. Support of our team.
Great. But it was wonderful.
So I think we are not getting any more questions. So I think we can close the session. We are on
Sure.
time.
Thank
So,
you.
Thank you, Ankush.
Thank you, Chaitanya ji.
Thank you.
Thank you very much.
So,
Thank
thank
you
you,
so much.
Ankush sir and Praveen sir, for the wonderful session of day 3 with respect to the role of products and materials in the building. So thank you, Chaitanya sir, for giving that welcome address. So thank you all the participants for listening on to the session, and post this we have 2 more webinar series which are planned for tomorrow and day after tomorrow. I would request everyone to attend those sessions also.
Thank
So
you.
which speaks about technology, and the last day we will be speaking on net zero.
Okay. Thank you.
Thank you, sir.
Thank you, everyone. Bye-bye.
Well, thank you.
Bye bye, everyone. Thank you, sir. Chaitanya sir, bye bye.